Question 3. Exothermic reactions transfer energy to the surroundings. Draw a reaction profile for an exothermic reaction using the axes in figure 1. Show the relative energies of the reactants and the products, and the activation energy and the overall energy change. Okay, so this, I have to draw that, I have to show these. It's worth 2 marks. So I know that for an exothermic reaction, the energy, so the reactants have energy, and what I get out of that is I get obviously the products, but the products have less energy because they've given some out to the surroundings. So the first thing I'm going to do is I'm going to draw, I'm actually going to use my ruler, so I know the reactants are here, and I know the products are going to be down here. Now I've got a bit in between, so this is my reactants, this is my products. Okay, I have to label those, so I have relative energies yes and yes. Okay, I know they've definitely dropped. And then what happens, this is during the reaction here, in between this line and this line, and what we get is we get the activation energy, which is this kind of peak, and then it drops like that. Okay, so I need to label the activation energy. Well, the activation energy is this amount here. So let's say activation energy. It's the height of the peak above what you've got to begin with, and then the overall energy change will be from where the reactants were, how much energy they had, how much the products have got there. So this is the overall energy change. If this was an endothermic reaction, energy would be entering, which means the products would have more energy than reactants. So it would look similar, except here this line would finish up here, okay, higher up. Okay. Part B. Combustion is an exothermic reaction. Calculate the, so it's a calculation question. Calculate the overall energy change for the complete combustion of 1 mole of methane in oxygen. Okay, so that's this. So I need to work out 2 things. I have to calculate 3 things, don't I, in total. I need to find the energy of the reactants, and I'm going to need to find the energy of the products. I haven't got much space here to write my answer, so I'm going to put a line down the middle. So I'm going to find the energy of the reactants over here, and if I look, these are my reactants over here, and what have I got? I've got how many of these bonds? I've got C to H. Well, there's 1, 2, 3, 4 of those. So I've got 4 of those. I've got an OO bond, but there are 2 of those. So I can look at C to H, and I've got 4 times 4, 1, 3 equals. So let's just see what that equals. So 413 times 4 gives me 1652. So 1652. I've then got my O to O double bonds, and there are 2 of those. So 2 times 4, 9, 8 gives me a total of 2 times 4, 9, 8 996. So the total equals those two added together, 1652 plus 996 plus 1652 is 2648. 2648. So I've taken my time really on this here. So I've got the energy of the reactants, and I know that's kilojoules per mole. Well, in fact, that's just kilojoules because I've actually got the whole. I've calculated the mole there. I've then got the energy. Let me just leave the. If I leave that unit on, that makes it easier, I think. So the energy of products. I'm expecting this to be lower because energy has been given away in that reaction. So look at my products. What have I got? I've got an O to C double bond. Don't need to worry about these now. O to C double bond, and I've got two of those, plus two lots of two OH bonds. So I've got two, because there's an OH there and there's an OH there, but I've got two lots of them. So 2 times 2 equals 4. So the energy here, I've got C to O double bond. Oh, I've got 2 times 805, and I've got O to H bonds, and I've got 4 of them in total, which is 4 times 464 equals, right, let's just check what I get there. So I get 2 times 805, 2 times 805 equals 1610, and I get 4 times 464 equals 1856. Okay, so look at that, plus 1610 is 3466. So the total equals 3466. So then I've got the difference. So energy change, and that's kilojoules per mole. Energy change is take the big number from the small number, 3466 minus 2648. So 3466 minus 2648 gives me 818. 818 kilojoules per mole. Okay, so 818. My 8 didn't work very well for some reason. Okay, so that's how we do it. So find the energy of the reactants, energy of the products, and take the big number from the little number, and that will give you the total energy change.